Welcome back to the deep dive. Today we're looking at something that's, well, it's basically invisible.
Completely invisible. We're talking about environmental monitoring systems.
The ones that protect all this high-value infrastructure.
Yeah,
But not physical security. We're talking about the air itself.
that's right. And our source material today is all about one specific piece of tech, the NTI optical dust sensor.
So our mission is what? To figure out how this thing actually works.
Exactly. How it works, what its most important feature really is, and this is critical, and then how it plugs into a bigger system.
Okay, let's start with the core mechanism. How does it, see dust in the first place?
Well, at its heart, it's actually elegantly simple. It's an optical setup.
Optical. So like a beam of light.
Precisely. It uses an infrared emitting diode, an IRD, that shoots a beam of light across a small chamber.
And I assume there's something on the other side waiting to catch it.
A phototransistor, yeah. And when any particle drifts through that beam, it interrupts it or scatters it.
And that's the detection.
That's the detection. But you have to remember, the sensor on its own it's kind of just an eye. Doesn't have a brain.
Ah, right. It needs to report back to something.
It has to. It needs to connect to an NTI server environment monitoring system. The E2D, E5D, one of those. Without that, you don't get alerts, you don't get a solution.
And these things are often in huge facilities, right? So that connection needs to cover some distance.
A huge distance. It uses a standard RJ45 connector, so think CT5 cable.
And the source is it can be up to 1,000 feet away.
1,000 feet, that's 305 meters. That tells you this is designed for, a sprawling data center, not a small office closet.
And it's not a power hog, I noticed.
Barely sips power, 5 volts and under 50 milliamps.
That is so important when you're talking about systems that need to run on a battery backup.
Okay, so it sees particles. That makes sense. But the thing in the source material that really jumped out at me was its ability to tell the difference between plain old dust and smoke. I mean, how does a simple optical sensor manage that? Well, that's the game changer. That's where it moves from just detection into intelligent threat analysis.
So what's the secret?
It's all in the physics of light scattering. Smoke particles from combustion are fundamentally different from house dust.
They're much finer, aren't they?
Much finer, and they have a different size, a different optical density. So when they cross that infrared beam, they scatter the light in a very specific, a very different way.
Ah, so it's not just seeing a blockage, it's analyzing the signature of the scatter. The algorithm knows that's not a dust bunny, that's a fire.
Precisely. And for the person running that facility, avoiding false positives is everything.
Right. You don't want routine maintenance stirring up dust, and suddenly the fire suppression system kicks in.
Can you imagine? That's catastrophic downtime you just can't afford. So being able to reliably tell the difference means the response is actually appropriate to the threat.
And for anyone deploying these, we should probably mention the practical details. It's pretty compact.
Yeah, about 5.9 by 2.3 inches. Handles a decent temperature range, too, from 0 to 65 Celsius.
And it's RoHS compliant, which is a huge deal for international rollouts. No compliance headaches.
Absolutely.
So to sort of wrap this part up, we've got a sensor using a simple optical system, but its true value is that intelligence, differentiating dust from smoke.
That's the core of it, yeah.
Okay, so here's the bigger thought I want to leave you with. We look at the other sensors NTI makes. The source mentions a glass break sensor, a noise level sensor.
The EGBS and the ENLS.
So if managers are now monitoring not just heat, but the exact sound of glass breaking or the specific type of particle in the air, what does that suggest about modern infrastructure?
It suggests that the definition of a vulnerability is getting much, much more granular.
It's not just about a big, obvious physical breach anymore, is it? It's about these tiny environmental anomalies that can cascade into total failure.
I think you're right. It's almost like the highest form of operational security now is having perfect visibility into the smallest possible problem, the things you'd never even see with your own eyes.